Hello, everybody. My name is Erica, and today we're going to be learning about the nature of science, how scientists understand the world. This can be found in Chapter 1, Activity 1 on pages 5 and 6. The first thing we're going to be talking about is the five senses. This is a great way to find out our observations because observations are descriptions of what is sensed through these. This includes sight, smell, hearing, taste, and touch. More about observations are that they can be verified and confirmed by other people using the same senses. This makes it a reliable fact since this test can be repeated and verified by many people. An example would be if you felt that a rock was sandy and saw that there were fossils, and then a peer with the exact same rock felt that the rock was sandy and saw that there were fossils. It can be determined that those are factual characteristics of the rock. Then, inferences. These are conclusions based on observations. Scientists use prior knowledge to try and figure out how the natural world works. Unlike observations, people can use the same facts and knowledge and come up with different inferences. This can get competitive, so experiments are designed to gather data and decide between the ideas. Now we dive into hypotheses. These are inferences when scientists are beginning to develop an idea. This starts when scientists form ideas and make predictions. Then they design experiments to test their hypotheses, and if it supports it, it'll likely be kept as an explanation, and if not, it'll be revised, and sometimes drawn out, other times it'll be revised and then retested until they can come to a conclusion. Next, we're going to be talking about models. These are useful inferences of how a process works. These show, explain, and predict observations. The photo on the left is similar to the ones that we saw in class. Next, we have theories. Theories are inferences over time with lots of experimentation by groups of scientists. It is important to know that these are not guesses, so it is not the same as your friend telling you about their theories for their favorite Netflix show, because that can often be a guess, while theories are very likely to be true because of the amount of evidence supporting it. These can include facts, inferences, and multiple tested hypotheses. An important one to take note of is that evolution is often regarded by a quote that says, "Theory not as a fact." Now, this is a very confusing quote because theory is considered a fact in the scientific world because it is the truth that scientists know. Getting into that scientific truth, scientists are taught to question, seek evidence, and push factual and known limits so that our knowledge can always be evolving and developing. Another scientific truth is that inferences are never claimed to be true because room is left for future developments and changes to established ideas. Ideas do consistently change in science, and comparing hypotheses and theories, hypotheses are more likely to change than the theories. And this is because hypotheses are just ideas that scientists come up with and then decide to test and see. But theories are the scientist's truth because of the great amount of evidence to support them. Oftentimes, theories are referred to as the truth in progress because they can still be modified or added to with new developments, but they are the most factual evidence and truth that the scientists do have to refer to. When it comes to collaboration, scientists in different places can collaborate by bringing their hypotheses, findings, perspectives, and various skills together to attack a certain issue. When sharing observations and inferences, their work can be verified, challenged, and used to help each other out. Now let's get into scientific law. What it isn't is an endpoint and the gradual progression of a theory to becoming a law. But what it is a descriptive generalization about how a part of the natural world behaves under certain circumstances. A scientific theory may incorporate scientific laws. An example of this is in the theory of gravity. Included is Newton's law of universal gravitation. However, it doesn't explain the whole theory, just a piece of it. So, while a scientific theory may incorporate scientific laws, a scientific law is not the whole scientific theory. Thank you for listening. I hope this was very informative.